So, hello everybody. So first of all, I want to thank you for the opportunity to be here, and a special thanks to Tilo and Fraunhofer IPA for hosting the event. My name is Pablo Quilez. I'm one of the co-founders of drag&bot, which is a small startup located here in Stuttgart. So we are 11 employees, and we are financed by venture capital. So our history is a little bit longer. So we started here in Fraunhofer at research projects, and after a couple of times, so we decided to move for a business plan. And there is a reason why this company exists. So it's because we identified different challenges which usually are happening in robotics today. The most important of them is that to use robotics in industry, so you need big expertise, a lot of know-how to use different robot manufacturers, so everything is specific. And this is expensive and difficult to find, so you need robot experts, which are hard to find. If we move to the scope of research, so typically you need more time just for setting up the environment, the working system, than for using your robot for the real research. So you want to do, imagine, so if you want to do a deep learning application, then makes no sense to invest more time in setting up the robot and the gripper to move rather than doing your research. And also flexibility comes into big scope, because once you have your application, you want to reuse it, and you want to keep this being used for the next task. If you just change the process, so you don't want to redo all your work. So this is, therefore, drag&bot comes so a software platform for easy graphical robot programming, so also the setup. In this case, our focus was always industry, so everything is industrial oriented. So we try to make companies, so small, medium-sized companies, to effective and costly effective, automate, even for small lot sizes. And we don't replace ROS, so we are using ROS. We try to be to ROS what Windows was for MS-DOS, so in the past. This is our vision. What offers drag&bot? So it's a human-machine interface for easy robot programming, so you can just program with drag and drop of function blocks. Experts, so like you, can be 5 times faster, so using the graphical tooling. And this allows workers for using robots which normally they can use, so they need one expert in the company, so with this they are on their own, so able to do the robotic programming and the installation. The interface, so it's the same for any kind of robot. So if you just change the robot, so a universal robot with a KUKA or Yaskawa, so it's going to work. So you're the same application, so you don't need to rethink everything. Plug and produce, we mean so you just connect the components, so a robot, a gripper, some vision cameras, and you are sure it's working. And it's ROS-based, so extends ROS capabilities, so with this graphical use. If you want to use normally ROS, so there is no problem, so you can continue using your ROS system, so because we are not replacing, so we are complementing it. Moving a little bit into technical details, so drag&bot is composed of 2 big parts. So one is the drag&bot studio, and the other one is the drag&bot runtime. So the studio is the web system, so it's a website where you can program. It's intuitive and graphical, usually running on the cloud. And the second part is the runtime, which is a ROS system. So we have everything Dockerized, so it's running in an industrial PC near to, so in the robotic cell. And you connect so this computer with all your components, so robots, cameras, so everything PLCs. You have control of the ROS, so you can access it, you can add new things. So as I said, so we are not replacing. Our standard architecture is this. We focus on the cloud, so for the website, so you program on the cloud, and then you deploy your applications in the computer. We discovered that this is very difficult for industry clients because they want to have everything offline, so there is no internet in the factory, so even just connecting, so with the telephone is quite hard. And therefore, so we also offer the possibility to have everything offline, so installed in the same PC. And there is one third variation of the architecture, which is everything on the cloud. This is especially intended for education. So you run robotic simulation, everything in the cloud. ROS is Dockerized, so it's running in a server. And this allows so to load different URDF models with different environments so for different simulations. We offer an example with a machine tending application, so which is interactive. You can pick parts. So it's more or less a small gazebo, but so we could be possible also to use gazebo for these simulations. Now imagine so you have drag&bot and you want to extend it. How you can extend it? So you can extend it graphically by creating new wizards and guides. So these are human interfaces. So wizards are for parameterizing function blocks, and guides are step-by-step guides. So yeah, it's like a wizard which is creating a program at the end. So graphically, so you have a bunch of steps, and at the end you generate a program template you can use or you can modify if you want. So with wizards, you set the parameters. So if one function block requires robot position, so you use some graphical representation for setting up the position. Everything is web technology, in this case Angular, and we offer a SDK for adding your own graphical interfaces. With going into ROS, so we can extend drag&bot with new drivers and new modules. So a driver is, as the name says, a ROS node which is connecting some hardware, so like a robot, camera, PLC. And the module is a little bit bigger because usually it relies on drivers and is a combination of different drivers and modules to offer a big functionality, so which can be computer vision, force controlling, or beam picking. Usually we also extend functionality of third parties in this case. And the last way to extend drag&bot is function blocks. You can create your own function blocks. They are Python based, and you control the ROS nodes with these function blocks, creating also inputs, outputs, sequences, logic, so, like traditional programming or like graphical programming. Let's see in detail how you can transfer a ROS package into drag&bot. It's very easy. So as you know, mainly ROS nodes are programmed in Python or C++. You keep your own ROS node, and you just need to add a status topic, which is relevant for us to inform the health of the component. So if there is some error with the connection, or the robot is in error state, or if the component is not running because of something. So this information is quite useful for industrial purposes. And you just need to create a configuration file, which is a YAM file, including the description of the node, which ROS launch is being used, and the parameters which you need to configure it graphically. So these parameters are nothing else but ROS params at the end. So it's one-to-one, the translation. Also, drag&bot offers a predefined Catkin overlay space. So it's like the normal space, so you can put your own nodes there, so there is a standard way. And at the end, so you create one component, you can use it graphically, so you can put it in drag&bot, install by one click, and just use it. So at the end, so you need function blocks. So for using your component, in this case, a function block is a Python script. So we see here some examples. So we offer an API for creating these function blocks. Is a template where you have different inputs, different outputs. You can do graphically, and Python script. So at the end, so it's quite a few lines of codes for creating ROS calls. Typically, it's a ROS call to a service or some topic subscribing, but also can be something very complex like computer vision, or you can also import TensorFlow and do deep learning if you want. And we see here one real example. So this is the digital I/O set we are using. So we are just calling a ROS service for setting I/Os, and this is going to the robot. We are activating one I/O. So let's go to another example. So this is, we see here Basla to the camera, driver, and also the vision components. So in this case, we package together so the Basla camera with some graphical functionalities. So in just a couple of notes. So one is the driver, which is the standard driver, is the official. So we are now the maintainers, the official maintainers of the ROS driver. And the extrinsic calibration module, which is translating position in 3D space from the camera to robot positions. Also, we package together the intrinsic calibration tool, which is nothing else but the standard ROS intrinsic calibration tool for cameras. We create a wrapper, and then we can use from our system, so graphically. There is different component configurations, so you just need to set up the IP address and which intrinsic calibration file you want to use. Also, this camera offers different profiles. And at the end, we package also pattern matching and object localization function blocks, so in OpenCV. So you have the whole functionality from OpenCV. Let's move to see. So until now, we supported a lot of different robots. So they are more or less the most important in the market. So a couple of them are coming in the next time. Also with grippers, we have a couple of specific grippers, but we support all input-output grippers. So if you connect with the device or the controller of the robot, you can use your own gripper. Cameras, so there is many cameras, so especially Basla. And we have also, if you have a ROS driver, so you can use in drag&bot. So you just need to include as component, you can do yourself, and it's very fast to include it. Big modules, so we have 4 until now, so Vision, which includes some OpenCV, so tools. Force controlling, this requires a fast interface for moving the robot. PLCs, so different kind of PLCs, and beam picking, which we use third parties for doing the functionality. For communication, it's the same. So we have communication with the Siemens, Modbus, or you just can use TCP/IP when you need. Let's see some examples now of real use of ROS in industry through drag&bot. In this case, this company had, so is a machine producer. They produces vending machines, this press you see in the video. And in this case, they designed a cell which they tried to sell, but the clients were accepted, or was difficult for the clients to reprogram the cell because they want to use different variations of the product, and this was really hard to use. Therefore comes drag&bot into the scene. In this case, so we designed so the graphical, so easy of use configuration for the cell, for creating and modifying the applications. So you just need to put the positions and set how big is the part you want to press, and you don't need to program anything, so it's everything pre-configured, and this allows users to just use the cell. Moving to another example, in this case, a real use in production of ROS and drag&bot. So in this case, there is a production line running with 2 robots in a mixed combination human-machine. The first process is a handling process, so pick and place, and the second one is screw. This is running 24/7, so it's in real production. And the advantage is that the maintainers, they can adapt so the line for new product variations very fast. So moving to another example, this In this case, it's a research corporate lab. They achieved to do this application in the video just in a couple of days by integrating new hardware, camera, and the robot. And this wasn't possible before. So in this case, so dragbot was quite useful to fast prototyping of new applications in the lab, which at the end comes into production. So we see how is the handling, and then there is a screw process. So in this case, the tool is controlled with IOs. So we just set one IO to activate and deactivate the screw. Exactly. You see here. As I said, these are real applications, so they are not research projects. Let's move to another one. Another customer which we had, in this case, the most important thing is they can extend dragbot with new functionalities by just programming a couple of lines in Python, and then they can include new computer vision things or the logic they know they want. So they don't need to focus on the application, so the hardware and the process itself. So they just, to build the cell, they just focus on the process itself, and the programming with dragbot is quite easy. So one last example is education. In this case, we offer dragbot for educational purposes. As simulation, the students can do their own programming of robots, learn robotics, and after they had learned everything, do one application, they can immediately translate to a real robot. In this case, it's an IVA, KUKA IVA, which is combined, so it's a dragbot there, so they can export the application, import in this cell, and they can run the application in the lesson. So they are also happy about this. Well, until now, maybe, so you are asking yourself why you need dragbot, because you are all robotics experts, and therefore, so probably you don't see the need for this. We have a couple of reasons. So the first of all, and the most important, is because dragbot allows you to focus on what you are doing and don't deal with hardware integration, component integration. In this case, you probably have a lot of trouble for integrating new hardware or modifying cells, applications, so you can abstract from this and just do your research. Also, you can extend the software with everything you need. So if you need a new module, so you can create it. If you want to use your ROS node, if you want to use Move It, if you want, you can use ROS normally. Also, with this, it's easier to create the cell, so the hardware, and if you need to change the task, so it's quite simple. So if you have a screw process, so you can change to handling process very fast. And if you do with one robot, you can move to another robot, and the same application is going to work. Also, your same ROS application is going to work. So to finish it, so dragbot is offered as licenses. So we have special licenses for research laboratories and corporate labs. Can be for one robot or floating, and in this case you receive one industrial PC, but also can be installed in your own PC, and of course support and training, so it's included. We have a bunch of different packages, so modules which you can profit, so like SDKs and computer vision, communication with PLCs, so force control. And good, with this is finished, so thank you to all of you, and if you have any kind of questions, so please.
Yeah, so we have short time for some questions, so if there's questions, if not, go.
Yeah.
I'm wondering how you model resource use by the components. I mean, you could put a bunch of components on one machine, totally overloaded, nothing would work. How do you prevent that?
Because normally the components we check, so the official components we check ourselves. So we take about the quality assurance, and we offer just components which are tested, and yeah.
But I mean, it's not that it's a bad component, it's just maybe a computer vision component might take a lot of CPU time, and you couldn't run 10 of them on one box. So is that somehow modeled?
Well, it's depending on the logic you build. If you are doing a computer vision process in parallel with another some CPU consuming process, then of course it's going to compete for the resources. But at the end, you have to think this is thought for sequences. So at the end, you do the process and then you move the robot because you get the position calculated. So it's not, this is not a big issue because also we are not doing the inverse kinematics. So the robot is always moving during the process. So, yeah, but of course this is always a risk you have to take care. That is a good question.
Okay, thank you, Pablo.
Yeah.
Thanks for the presentation very much.